Hello everyone. The topic I am going to discuss is about psychrometry, which comes under low temperature storage systems. In this, we are going to discuss about what is psychrometry, properties, measurement, and psychrometric chart. First, what is psychrometry? Psychrometry is the branch of engineering science which deals with study of moist air, that is, the dry air mixed with water vapor or humidity. It also includes the study of behavior of dry air and water vapor mixture under various sets of conditions. Through the Earth's atmosphere is a mixture, though the Earth's atmosphere is a mixture of gases including nitrogen, oxygen, and argon and carbon dioxide. Yet the purpose of psychrometric is considered to be a mixture of dry air and water vapor only. Why to study psychrometry? To be able to analyze various processes involving moist air. For example, if the air is warm and wet, what will be the air conditioning design required, such etc. Important psychrometric properties: dry bulb temperature, wet bulb temperature, which is measured in Fahrenheit or Celsius, humidity ratio, which is measured in gram per kg or grains per lb, relative humidity, which is measured in percentage, dew point temperature, which is again measured in Fahrenheit or Celsius, specific volume, which is measured in meter cube per kg or cubic feet per lb, then finally enthalpy, which is kilojoules per kg or BTU per lb. Dry bulb temperature. Dry bulb temperature or DBT, it is the temperature of the moist air as measured by a standard thermometer or other temperature measuring instruments. Then wet bulb temperature. Wet bulb temperature is the temperature recorded by thermometer when the bulb is enveloped by cotton wick saturated with water. The accuracy of a simple wet bulb thermometer depends on how fast air passes through the bulb and how well the thermometer is shielded from the radiant temperature of its surroundings. Wet bulb depression. It is the difference between dry bulb temperature and wet bulb temperature at any point. The wet bulb depression indicates relative humidity of the air. Humidity ratio or specific humidity. Humidity ratio or specific humidity W is the mass of water associated with each kilogram of dry air. Assuming both water vapor and dry air to be perfect gases, the humidity ratio is given by W equals mV by Ma, where mV is mass of vapor, Ma is mass of dry air, and its unit is given by grams per kilogram or grains per lb. Next, we are going to see about relative humidity. It is defined as the ratio of the mole fraction of water vapor in moist air to mole fraction of water vapor in saturated air at same temperature and pressure, where it is given as phi equals mV by ms. In this, the relative humidity is normally expressed as a percentage, where the phi is 100%, then the air is saturated. Dew point temperature. If unsaturated moist air is cooled at constant pressure, then the temperature at which the moisture in the air begins to condense, which is known as dew point temperature, which is dBT of air. The dew point temperature is also known as saturation temperature. Next, about dew point depression. It is the difference between dry bulb temperature and a dew point temperature of air. Degree of saturation, mu. The degree of saturation is the ratio of humidity ratio W to the humidity ratio of a saturated mixture Ws at the same temperature and pressure. Mu is equal to W by Ws T, P. Enthalpy. The enthalpy of moist air is the sum of enthalpy of dry air, sensible heat, and the enthalpy of water vapor, latent heat. The total enthalpy is given as sensible heat plus latent heat. The sensible heat, which is enthalpy due to change in temperature, and the latent heat, which is enthalpy due to change in humidity. Calculation. Sensible heat is calculated as 1.08 into CFM into dry bulb temperature 2 minus 1. Latent heat, it is 0.68 into CFM into dry bulb into W2 minus W1. Total heat is 4.5 into CFM into H2 minus H1, and total heat is given as sensible and latent. In this CFM, which is airflow rate in CFM, dBT is dry bulb temperature in Fahrenheit, W is the humidity ratio in grains per lb, and H is the enthalpy in BTU per lb, and heat is given as BTU per hour. The enthalpy of moist air at 0 degree Celsius is given by H equals HA plus W Hg, which is equal to CPT plus W into HFG plus CPW into T. The unit of H is kilojoules per kg of dry air. Substituting the approximate values of Cp and Hg, we obtain H equals 1.005 T plus W into 2501 plus 1.88 T. where T is dry bulb temperature of air vapor mixture at 0 degrees Celsius. W is humidity ratio, which is kg of water vapor per kg of dry air. Humid specific heat. From the equation for enthalpy of moisture, the humid specific heat of moisture, it can be written as Cpm is equal to Cp plus W into Cpw, where Cpm is given as humid specific heat, which is kilojoules per kg Kelvin, Cp is specific heat of dry air, which is kilojoules per kg, and Cpw is specific heat of water vapor, where W is humidity ratio, which is kg of water vapor per dry air. For all the practical purposes, humid specific heat of moisture, Cpm, it can be taken as 1.02 kilojoules per kg Kelvin. Specific volume. The specific volume is defined as the number of cubic meters of moist air per kilogram of dry air. Its unit is given as meter cube kg of dry air. It is used to calculate the mass flow rate of air, where specific heat is given as V by m, which is rho inverse, which is reciprocal of density. Thermodynamic wet bulb temperature. It is the thermodynamic property and it is independent of the path taken by air. After the adiabatic saturator has achieved a steady state condition, the temperature indicated by the thermometer immersed in the water, it is known as thermodynamic wet bulb temperature. The thermodynamic wet bulb temperature will be less than the entering air dBT but greater than the dew point temperature. It is given as H1 equals H2 minus W2 minus W1 of HF, where HF is the enthalpy of saturated liquid at some or thermodynamic wet bulb temperature. H1 and H2 are the enthalpies of air at the inlet and exit. W1 and W2 are the humidity ratio of air at the inlet and exit respectively. Then wet bulb temperature, wet bulb thermometer. It is not convenient in practice. It is not convenient to measure the wet bulb temperature using an adiabatic saturator. Instead, a thermometer with a wetted wick is used to measure the wet bulb temperature. It can be observed that since the area of the wet bulb is finite, the state of air at the exit of the wet bulb, it will not be saturated. Instead, it will be pointed to on the straight line joining one. By performing energy balance across the wet bulb, it can be shown that the temperature measured by the wet bulb thermometer is T2 is equal to T1 minus Kw by Hc, HFG, W minus W, where Kw is the mass transfer coefficient for air mixtures. Hence, in this video, we have seen about what is psychrometry, why psychrometry is important, what are various psychometric properties, and what are the two thermometers which are used to measure psychrometry. Thank you.